All right, so let's get started. My name's Tim Homan. I work for MITRE. I support folks at C3T, at APG, and I support CERDEC. So they've asked me to moderate this session, so I'd like to get started right now. Thanks. So I have a prepared little introduction here I'd like to get through. So traditionally, the Army's platform community has been faced with challenges in keeping pace with the rapid evolution of technology. And no matter how great the technology is, providing our soldiers a strong advantage, it has a minimal impact if you cannot effectively integrate that in a timely fashion. So in short, the Army is working forward through CERDEC to improve the engineering agility of our systems and trying to improve the actual C4ISR systems to afford the soldiers this more rapidly fielding of technologies. So to that point, the Army S&T community is addressing the challenges with a uniform open systems architecture. It'll allow a faster, more flexible hardware and software upgrade for the tactical edge. And so this effort is known as hardware-software convergence. And not only will this enable the agility of the Army to deal with unprecedented future needs, it'll also help to reduce directly on the platforms the swap, the size, weight, power, and cooling aspects. It'll also help to reduce redundant systems on these platforms, and in the long term, save time, money, and things related to the logistics support associated with the future retrofits of these platforms. So, in addition to this brief, there is a display over in the next door here, the hardware-software convergence display. There is an actual prototype printout model of the hardware that's being talked about today. So you're welcome to step over there after we're done with this session. So I'd like to introduce the panel today. Joining us from the Army Communications Electronic Research Development and Engineering Center, CERDEC, is Mr. Benjamin Peddicord. Mr. Peddicord serves as the Chief of Intel Technology and Architectures Branch in CERDEC, their Intelligence, Information, and Warfare Directorate, ITWD. He is also the CERDEC lead for the hardware-software convergence effort. Next to Mr. Peddicord is also from CERDEC is Mr. Ronald Kane. Mr. Kane is a systems engineer in the Architecture Standards and branch of CERDEC's Space and Terrestrial Communications Directorate, S&TCD. And he is also the S&TCD systems engineering lead to the CERDEC hardware-software convergence effort. And our third panelist is Mr. Mark Kitz from the Program Executive Office of Intelligence, Electronics, Warfare, and Sensors, that's PEO IEWS. Mr. Kitz is the chief engineer for PEO IEWS, and they strive to deliver the Army's sensors for intelligence, force protection, and increased platform survivability. So Mark works to integrate sensors and technologies across these domains. So once the panelists have done their briefs and provided some remarks, we'll take questions and answers from the audience. And with that, let's begin the discussion with Mr. Ben Peddicord.
Good afternoon, everybody. Again, I'm Ben Peddicord, Chief of the Intel Technology and Architecture Branch at the Communications Electronics Research and Development and Engineering Center, CERDEC, I2WD. Glad to be able to talk to everybody today. I don't want to take a lot of time with slides. We just each brought a few slides. Really, we'd love to have your questions. We'd like to have a true panel discussion and do questions and answers with you. So I'll try to go pretty rapidly through my slides. I won't go through all the details of them, but we're happy to have detailed discussions later with any of you at any level of detail that you're interested. Could move on to the next slide, please. So really, as Tim mentioned, what motivated this effort was that there are a few major motivations. To me, the most important problem that we're trying to address is that it takes too long to deploy new capabilities to the field. So if we accept the idea that we can't predict the future and that we need to be agile and we need to be able to adapt our systems to a changing threat environment, then we need to build them differently. We need to do something different so that we can drop in new capabilities rapidly. And one of the solutions to doing that is to build truly open and truly modular systems to allow new capability to be dropped in without having to tear out all the existing capabilities, so that we can add a little bit, add an extra piece where we need it, combine it with the existing pieces on the platform, and move forward with the new capability. Another problem that we're trying to address is that we have more capability that's important to the warfighter that we want to put on our platforms than will fit. And even if it fit, there's not enough power to run it all. So we need to reduce the size, weight, power of our solutions. One of the approaches to reducing the swap impact of our solutions is to share hardware where appropriate. So a lot of times right now we have unplanned and unnecessary hardware redundancy on our platform. So we need to optimize things a little bit more. We need to be able to share information from sensors. If we have a sensor that provides information for one application, we should be able to share, and we have another application that needs the same information. I think it should be obvious that we shouldn't have to put 2 copies of the sensor on the platform. We should be able to sync that information from that sensor into multiple applications. So we need to be able to share hardware where appropriate. We need to be able to exchange information easily between our missions so that we can rapidly adapt, again, to a changing environment, build a synthetic application that consumes information from multiple sensors and then commands actions in a flexible manner. And then finally, we need to improve our logistics chain. So we need more commonality between parts. So if we have 2 parts that are in essence an Intel CPU with some memory on it, they don't necessarily have to be unique parts. And even across services, that there can be more commonality. So the work that we've done here standards-wise is very well coordinated with the Navy. So it's jointly funded with the Office of Naval Research. In fact, I should have invited ONR to sit on the panel. But we've been doing a lot of work through the various standards bodies with our Navy partners, also with the Air Force, and we are finally, I think, doing the engineering work on the government side to give meaningful answers as to for what we want when we say we want modular open systems. I'm going to take you slightly through that. So when people talk about modular open systems, they talk about it in all sorts of different ways. A lot of times they talk past each other because they're talking about it at different layers. And a lot of the different pieces, they're actually all important. They're important for different reasons. And we wanted to put them together into a coherent suite, and we wanted to support a very broad set of applications. So we got together across CERDEC. So we got night vision and doing the optical sensors. We got the CP&I directorate that does precision navigation and timing. We got the Space and Terrestrial Communications Directorate doing comms, ITWD doing EW and SIGINT. We got our TARDEC friends, we got ONR, and we looked at all the applications we want to build, and we looked at standards that we could all agree on to use across those applications. So first of all, one of the things people talk about when they mean open modular systems is that sensors on a platform should be connected to a network and should be able to exchange information easily, right? That's one level of an open system architecture. So when we talk about that, we all agreed that we could build on top of the Army's work with Victory, which provides an Ethernet bus and standard management interfaces and data exchange. So that's one piece of the puzzle. Sometimes when people talk about open modular systems, they mean that they want to be able to easily install some embedded computing element or some piece of hardware in the platform. So on that side, we leveraged a lot of work that's been done through the VITA standards body and the Open VPX work, so that you get electromechanical connections, you get your heat dissipation strategies, the size, shape of your embedded computing, and your ruggedization strategies standardized. We took VITA 65 Open VPX. We've embedded engineers into that work so that we're really meaningfully involved on the government side, and we've developed profiles which meet our needs and which will actually provide the interoperability that was the original goal of Open VPX. Then, when you look at our platforms, nearly all of our platforms have RF systems, whether it's a communications device, whether it's an EW device maybe for counter IED, whether it's an electronic attack device, whether it's some sort of platform survivability equipment, there's almost always some sort of RF component. And a lot of times the RF devices are a lot of the big swap consumers on our platforms. So we wanted to provide a useful modularization and as simple as possible modular open architecture for our RF components. So we developed what we call the modular open RF architecture, which exposes key interfaces, allows us to make truly open, simple to build RF systems that enables hardware sharing between applications and also allows us to insert new capabilities fairly rapidly. And finally, sometimes when people talk about modular open architectures, they're talking about software. They're talking about portable software, that they want an application to be written once and run multiple locations. So we've made sure that in our development of this, we've paid attention to that, and that we've explicitly supported Red Hawk for the Red Hawk framework for portable RF applications, the AFCEA for portable RF applications, and also FACE, the future air capability environment for both avionics and kind of general purpose portable software applications. So we've looked at this whole thing and we've put it together, and the way that we've built, matured, and gained confidence in these standards is by building reference implementations of the applications we want. So we built SIGINT, EW, comms, precision navigation, timing, mission command applications, and we've integrated them successfully in our lab at APG, and we're doing that on an annual basis where we bring more and more capability in at a higher and higher TRL. Next slide, please. So I've got to be cognizant of time. I'm not going to go through this slide in detail, but I just want you to know, and I've got a whole bunch more slides on this. We've gone through these things in the VITA committees with industry partners to the pin level, talking about how you use a VPX, a 3U VPX connector, so that you can get actual true interoperability. So you don't have user-defined pins that are maybe not only not interoperable, but they may be incompatible, where they'll actually damage each other if you shove them in the wrong backplane. So we've done the work there. We've proposed our profiles. We've done that in common with the Navy. We're sharing now 3U VPX cards with ONR in our projects. And all the details are available. We can discuss that, as far as you want. Next slide, please. And then finally, a quick description of what modular open RF looks like. So the modular open RF architecture provides common, standard, simple to implement interfaces for our RF components. And then conceptually, when it comes to procurement time, we envision these interfaces being packaged in useful blocks of hardware that can be left in when we upgrade or change the way we're building an RF system. So one important example of that would be what we would call a radio head, which would be some hardware that incorporates an antenna, a PA, an LNA, some filtering elements, is connected to a standard RF distribution bus, exposes standard management, non-real-time management interfaces over our Victory data bus, and responds to low latency signaling over the Mora low latency bus. So these standards exist. We have reference implementations of that available. Along with the radio head, we also conceptually have developed what we call the RF distribution device, which allows you to route an RF signal, whether it's digital or whether it is a low-power analog signal, or whether it's RF over fiber, from a signal processing unit to a radio head. And then finally, you have what we call the software-defined radio, which hosts your high-performance radio processing. And I shouldn't have said finally, because actually the final unit is a shared processor, which really is envisioned to host things like user applications and high-level management functions. So with that, I'm going to let Ron from S&TCD take over and talk to you a little bit about some of the comms applications that we've been developing within this framework.
Good afternoon. I'm Ron Kane from CERDEC S&TCD. So our role, in addition to talking about the development that Ben was talking about with the OpenVPX, the Mora, the Victory, and some of the other open standards, was to actually do an instantiation of a comms waveform and demonstrate that. So what we did is we took the soldier radio waveform, SRW, primarily because number one, we have a lot of knowledge in that area, and it defined both a CNR voice and a data capability. And so using the open standards that are listed below that Ben had already discussed, so we instantiated that, and we built on the 3U OpenVPX module an instantiation of SDR that was running SRW. And important to that is it truly was an SDR in that it's not limited to SRW, so it's capable of running any of the jitters waveforms. So we did that. We tested it out with programmer record radios, brought it into our labs, our C4SR system integration lab, connected it to a fairly robust network of about 15, 20 nodes, and actually did testing, watched it form a network, watched it pass voice, watched it pass data. So it was capable of operating as interoperating with the program of record radio. Next slide. So what we're doing now, as we go through the final phases of developing our hardware convergence program, is actually working with PEOC3T to transition the technology over to them, showing them how to employ these capabilities to build communications radars to support mission command, and also looking at some of the challenges that they may face going forward. So the SDRs that we're looking for, so now we want to extend them past jitters and actually be able to support the WIN-T waveforms, getting 2 channels of comms capability on a single module, And also support for VITA 49.2, the VITA radio transport that Ben discussed, being able to move RF across the platform in a digital format over Ethernet links. Also, building more robust radio heads so that we can support truly a tri-band antenna with amplifiers that can do simultaneous operation in all three bands. And again, the radio head supporting VITA 49.2. Also, ensuring that single board computers and the storage modules can support the needs of mission command, and also building the chassis, the modules, and able to support operation in the harsh environments for the heavy combat brigades. With that, I'll turn it over to Mark. A couple more slides on.
Sure. Good afternoon. My name is Mark Kitz. I'm the Chief Engineer for Program Executive Officer for Intelligence, Electronic Warfare, and Sensors. We build the Army's intelligence, electronic warfare, force protection, collection sensors for the Army. Why is PEO IEWS here? Why at a communication conference is it really important for us to talk about hardware and software convergence? Because the threat is very dynamic. The communications infrastructures that we have today is very brittle and fragile to how we conduct our jamming operations of tomorrow. So it is very important for POC3T, CERDEC, to do collaborative, community-based development in environments such as hardware and software convergence. Hardware and software convergence as a concept provides a really unique opportunity for the acquisition community where we normally do development and procurement of items that then bolt on platforms and integrate essentially at the platform. This concept provides a really unique opportunity for these programs to do more intrinsic integration. As we talked a little bit about the different VITA standards and the different backplanes, we can get to a great example is position, navigation, and timing today. Just the sensors that PEO IEWS brings to the ground platforms leverages multiple PNT sources. They bring their own. Each of those capabilities bring their own. Hardware and software convergence and Victory Standard, through those standards developments, we can get to a more integrated solution where we buy back the swap on those platforms, and we deliver a more cyber-hardened, cyber-opportunity environment for our IT infrastructure that we put in these tactical environments, lowering our threat vectors, and then important for our PEO, increasing our opportunity to conduct offensive cyber operations given the RF environment and given that all of these capabilities are executed in the RF spectrum. Yeah, I think I talked a lot about this common infrastructure and common software. That is a great opportunity for our PEO. In this chart, I just kind of highlight three different programs at a much higher level than what Ben and Ron had talked about. But we have three programs actively going after risk reduction and S&T activities around hardware and software convergence. One is an EW capability against RCIED threats, which is CREW. Another is RIM, which is interference mitigation. Think as we jam against EW threats, we have to be able to communicate as we jam. And active interference gets after some of those capabilities so that we can ensure that we can communicate in these contested environments. And then lastly, on the ground, we're still trying to conduct intelligence collection, right? We're still trying to offer freedom of maneuver and more accurate commander decisions. All of these three systems have to operate in this contested environment. And so hardware-software convergence, if you can go to the next chart, please. Hardware-software convergence is really an opportunity then for these types of systems to be developed in a more collaborative way. Long-term, so we don't have to get after interference mitigation or notch-tunable filters bolted on the side of a platform, but we can get to a more seamlessly integrated RF environment through the implementation of some of these standards so that we can reduce the SWaP-C and can start to break down the boundaries between, these artificial boundaries really, between how these programs do development. So I apologize for the way overly simplistic chart here, but it really depicts that these programs of record built on systems that, this concept really gets away from, and we can start to build card level or even dual use systems that can leverage each other's capabilities in a single platform. And I encourage you to go over to the booth to see some of the work that CERDEC and Ben's team have done conceptually and really getting after physical implementations of these capabilities. I know with RIM, we've already developed 6 cards and are working towards active interference cancellation in an S&T environment. So I encourage you to go see that. Next chart, please.
Sorry. Getting there.
So I also encourage you, my boss, General Vomek, will be here tomorrow speaking to the general session on sort of rapid acquisition and rapid innovation. I encourage you to go see his talk tomorrow. Why I have this chart here is how does the PEO, foresee taking some of these S&T investments? There have been a lot of work in industry in this environment, especially with 3U OpenVPX and implementation of a lot of these VITA standards. I guess the key takeaway that I want to leave you with is the government, the PEO, wants to get after more experimentation, especially when we talk about contested electronic warfare environments and offensive cyber and dual-use capabilities. We want to see a further investment in exercises like Cyber Blitz and Cyber Quest and Vigilant Hammer, where the industry, government, S&T, and academia can actually exercise these capabilities, and the Army can better learn how to operate and build TTPs and go after future programs around some of these concepts. Because honestly, especially in the EW realm, exercising those capabilities has become a lost art in some cases. And so then integrating those to the communication platforms, integrating them in a way that we want to operate to ensure that freedom of maneuver is something we need to experiment with soldiers in contested environments so that we understand how they will integrate. And so what we like to see is more of this rapid prototyping, rapid acquisition model centered around experimentation and sort of incremental delivery. And you'll see a lot of that in our future IEWS solicitations and how we get after executing our acquisition principles. So with that, I think I'll hand it back over to you, Tim. And
all right, thanks.
That'll be all.
All right, so I want to thank the panel. Right now we're going to do questions and answers, and we really want to hear from the audience what their questions are. So if you would, and you have a question, please use the microphone. We have a lot of background noise here. So anybody have any questions out there? If not, I'll ask some questions. So, all right. Anybody? Oh, there we go.
Yeah.
Go ahead.
I don't know if this is alive or not, but anyway, I'm Joe Matola, and my question has to do with active RF sensing. So have you guys looked at radar? There have been battlefields rolling to radars and things that will detect helicopters and all that sort of thing. This looks like a great RF platform. Does it extend beyond the domains that you've looked at so far? Thanks.
Yes, great question. And, I tried to keep the briefing short, but we're actively doing, so on the radar side, both from a sensing perspective, we are looking at ELINT applications and building them. We're also looking at building radar applications natively in this same construct. So the radar division within I2WD is actively pursuing that now.
Anybody else? Okay, I'm going to turn to a question to Ben. I'll start with you. What kinds of problems have motivated your work with regard to hardware-software convergence?
Well, as I said earlier, I think to me the most important problem is to be able to deploy new capabilities rapidly. I mean, there are technical solutions to reducing swap that don't involve an open modular architecture, right? And in fact, if you're going to be honest, the least swap solution would probably be tightly coupled, not modular at all system at all. But I started my career for the government not long after September 11th, and ever since then, the most frustrating thing to me has been to see these capabilities we could build in the lab that the soldiers needed that would take years. We could build these capabilities in months in the lab, and they take it 5-6 years to show up in the field. And to me, it's just not, that's not acceptable. So if And that work really informed what we did here. We looked at the interfaces that we would have actually used to have deployed the various capabilities we built over the last 10 years. We said, what interfaces did we need to do that? And let's control those interfaces, let's define them, and then that will allow us in the future to react better. So we don't want to define every interface. In fact, we want to define as few interfaces as possible. We don't want to spend a ton of effort and money managing standards and things like that. And we also don't want to tie the hands of you guys. We don't want industry's hands to be tied any more than has to be. We want you guys to innovate and build your IP into boxes that will appear for us. But what we have to do is plan for a future we can't predict and make it possible to insert new capabilities rapidly. So that, to me, that's the number one capability. I mean, there's also swap concerns, which I think we've shown we can actually make very, very real improvements on swap and very big improvements on the logistics side. And if you're a logistics guy, you love the logistics thing. If you're a swap guy, you love the swap thing. For me, as a technology guy, I love the ability to put in new capabilities rapidly.
So I think, if you don't mind, so I think it also breaks down sort of some cultural barriers. This concept is really disruptive in the acquisition community. We can have a lot of different PEOs sit up here on this panel with very different perspectives, whether that's the platform owners in aviation or ground combat systems. There are a lot of, or the PNT folks, in executing this concept and getting after this rapid capabilities. It really will take a community effort teamed with industry, because today this is not how we build systems, right? Today we each PEO delivers a system and it integrates sort of at the platform level, and so this is certainly a cultural change for Army and something we need to get after and tackle together.
Thanks. So anybody else in the audience with a question? All right, here we go.
Sure, I have what I hope is a somewhat easy one. When it comes to dealing with these new systems, and even with old ones, software has an annoying tendency to not be perfect the first time out. Do you foresee any strategies for better testing and quicker deployment of software updates during maintenance?
So I think it's an excellent question, and we've been trying to work with ATEC to try to address, I think, overall, how to do testing better and how to make it possible for us to more rapidly test as part of the fielding process for capabilities. I will say, I think one of the important things we've done on the software side here, when you look at these interfaces, is we've taken advantage of the reality of today, which is that computing is relatively cheap, both in terms of swap and in raw dollars. So, I mean, in the old days, it was expensive to put a processor on nodes, but these days it's very inexpensive to have intelligence embedded all throughout the system. So that has enabled us to make very loosely coupled interfaces for all of these systems. So a lot of these interfaces are web services type interfaces, which I think should help with that. Should help, I think, a great deal with that problem. And that since they're very loosely coupled interfaces, they run independently and without dependence upon each other. I think it should make the testing simpler, and it also makes it easier for us to not break things when we do integrate new capability in. It's a very loosely coupled system, and it takes advantage of really the change in the cost of computing over the last decade or two.
I also think that you do an investigation into frameworks like FACE helps you to standardize the development and the management of those applications across multiple platforms. So I think incorporating those types of interfaces into and frameworks into our standards really helps a lot in terms of simplifying the development.
And I think there's a basic understanding that sensor systems should be treated like IT systems now, right? They're mostly software based, and we upgrade, IT-based systems quarterly or yearly. Sensor systems should be treated similarly, and that's not typically how we have treated the sensor systems in the past. We test them, we field them, and they stay out for a long time. We need to treat them like the IT systems that they are today.
Okay. Let me ask the panel a question here. Ask Ron Kane. Some of the challenges that you're facing for hardware-software convergence, could you relate those to some of the deploying communication capabilities on Army platforms?
So when you talk about some of the challenges, so right now with a lot of across the fleet of platforms, it's very difficult to integrate a radio on a platform. You look at, we have multiple types of radios, like a maneuver radio and a man-pack radio, to provide all the capability that the platform needs to communicate. What hardware convergence does is it modularizes everything, brings it into a common form factor. So whether it's on a heavy platform, a light platform, it's really going to be the same installation. It's putting the chassis there, and the chassis doesn't have to be one standard size. You could have a vehicle that only needs a couple channels of comms and maybe one or two mission command applications. Or if you have a heavy platform, a command vehicle that may need 6 or 7 channels of comms and run many more mission command applications and intelligence applications, that you basically, you size your chassis, you do your space claim, and then in terms of being able to then to integrate new technologies that come along, it's a matter of pulling cards in, pulling cards out, and putting new cards in to increase the capability. If you're with comms capabilities, it's a matter of just upgrading software to SDRs that are quite capable of running waveforms across a multitude of waveform applications. So I think that, and then I think some of the real challenges that we're going to face going forward are, again, as I alluded to in my briefing, was looking at radio heads that can support all the different waveforms with all their power requirements, and also ruggedizing the chassis and the modules to meet some of the stringent requirements of the heavy platforms.
Thanks, Ron. So another question here for Mr. Mark Kitz. Industry, partnering with industry. Do you have any thoughts on how industry can partner with the government on this concept, or how we can help them to partner with the government?
Yeah, so I think, we've already started to add open systems in a lot of our solicitations. So I think a lot of the information that we're talking about has already started to make its way into the RFPs that are on the street. I also encourage cooperative research and development agreements with CERDEC. We've done some efforts in hardware-software convergence to collaborate on investments that industry have made. This way we can share information more effectively with our S&T partners. And then I think we've got a planned future industry day for the PEO IEWS in calendar year 2017, and we plan to make this a topic as part of our specific program briefings in that industry day, so they can understand how some of these open system standards apply directly into the systems that we develop. But really, I would emphasize that this concept has really been worked in the S&T and CERDEC, and any investments would make sense through a cooperative research development agreement. Has been very effective for us in a few different examples.
And just one other thing, just to piggyback on what Mark said about Industry Day in 2017, is that CERDEC is also working with C3T right now to host an Industry Day that we hope to have within the next 2 or 3 months. So, and that'll be advertised on FedBizOps when that's ready to hit the streets.
Thanks. Let me go back to Ben here, and let's see. So can you talk about some of the partnering that you've done through your development process with external partners and academia as well as the industry?
Yeah, so we've got a really great broad support, a lot of folks supporting us. I wish I'd brought my chart of partners because I'm going to miss a whole bunch of important ones. Lincoln Labs, Penn State, Johns Hopkins, ONR is jointly funding a bunch of our work. We've the Air Force Sensor Open System Architecture, SOSA, is completely coordinated with this. We chair one of their working groups, and they're building on the same suite of standards. We have a good partnership with NavAir PMA 209, and so you may hear of their host. So they kind of kicked off FACE initially, now they have host. Host has been coordinated with our VPX work. We've got a number of international partnerships we're working with, so a lot of our Five Eyes partners are working with us to use some of the same standards. Within the Army, TARDEC and MRDEC are partnering with us and assisting in this effort. We're doing our lab integration at CERDEC right now. CERDEC will be doing a vehicle integration of this year's demo equipment later next year. So we have really pretty broad support, and we're starting to already see the benefits in terms of being able to rapidly do things. Because there are some O&R programs that are doing similar things that we're doing in the Army, and we needed similar parts. And because we'd already agreed to use the same profiles and standards, we just exchanged parts with each other. So O&R is going to be flying one of the cards that we developed in one of their pods, and they didn't have to develop that. They didn't have to stop the program and develop that card. And we're going to pull some of their RF capabilities, and it will just work in our chassis. So it's really exciting to work across services and internationally on this.
Thanks, Ben. I don't think that's us. So going to go back to look to the audience. Any questions out there? So, okay, I'm going to look over to Mark. And so we've heard a lot about the technical challenges being addressed here with hardware-software convergence. And of course, there are always the programmatic challenges. And I was wondering if you have any thoughts about the programmatic challenges facing this program.
Yeah, and as I mentioned before, there are a lot of sort of moving parts and pieces of the community in integrating a capability like this programmatically. But typically it comes down to the modernization of each of those capabilities and aligning the hardware-software convergence investments with how each of those capabilities get modernized. It's clearly a very big challenge and not something that we'll tackle in the very near term, which is why I highlighted those sort of 3 programs, because those 3 programs in the next POM cycle will have modernization opportunities for something like hardware and software convergence to get after. But it will be very complicated for the Army to sort of digest this communications, electronic warfare, intelligence, all of these different programs, diverse programs executing modernization around this concept will be very challenging to execute culturally and fiscally. So I think that over time we've got to mature how each of those programs get modernized, and then essentially build it, and all of them will come. And that is kind of the strategy we've undertaken at this point, and then including them in our future solicitations so that industry can get after those standards when the program is ready to be modernized. But it is a significant challenge that we have to acknowledge up front in an effort like this.
Thanks, Mark. And Ron, I'd like to ask you another question. The benefits, I know we've touched on them. I'd just like you to reiterate some of the benefits that this could be bringing forward for the platforms, for the soldiers, and
so you said a key word there, soldier. I mean, we stood up here and we talked about the technologies that we're developing and what the benefits are in terms of swap and everything like that. But it really comes down to is how are we benefiting the operators? And so I previously alluded to that we have multiple radio systems on the platforms right now, and the operators, they have to learn how to use the interfaces across 4 or 5 different radios. So part of what hardware convergence is also doing is actually collapsing those 5 interfaces or 6 interfaces, depending on how the number of radios on it, into a common GUI. So what you're doing is you're unburdening the soldier from having to learn 5 different interfaces and the training that's necessary in order to them to become proficient with each radio. So part of the hope of hardware convergence is also to ease the burden on the soldiers as he's deployed and fight the fight.
thanks, Ron. So anything else from the audience out here? So I'd like to ask the panel. Oh, here we have someone. Yes, sir.
One of the strengths of modularity is always when you get high demand across the fleet deployment of systems, when you take maximum advantage of your swap C. Sometimes also there's, though, if you have unique requirements and unique environmental requirements that do not integrate easily into your design solutions that you have pre-planned. For these unique type of requirements and environments, how do you plan to integrate these solution sets into your general force structure? Will it be by exception or by over time integrating it into the next fieldable cycle of your next version of your platform? How would you planning on doing this?
I think there's multiple answers and aspects, and there's a whole bunch of different aspects to a question like that. One of the things I should have highlighted when I briefed the standards is that So this is a suite of standards. Each one of those standards does something useful on its own. They're atomically useful standards, and they address some aspect of a modular open system from some perspective. So you don't have to use them all necessarily all the time. When you put them all together, you get something more than the sum of its parts, but there may be some cases where some of these standards don't make sense for a particular application, but other pieces do. So they're independently useful, they're independently maintained and kept up to date. So there may be exceptional cases, and in fact I'm sure there are exceptional cases where it doesn't make sense to use one of the standards in a certain application, but it doesn't mean you can't use the rest of the standards. And I will also say that I think in general the standards we're defining shouldn't put constraints on in terms of your ability to ruggedize solutions. Most of these things are software interfaces, the exception to that being the OpenVPX work, but that's very widely ruggedized and deployed anyway, just in a non-interoperable way.
Yeah, I'm trying to think of a good example, but clearly we're not parochial that this is the answer to every question, right? But yes, right, we've been very successful in rapidly taking requirements and bolting on capability, and if that's what we need to do in the future, we will absolutely do that. However, I think we're highlighting an opportunity around all these standards to be more rapid in delivering capability that is software-based, that can leverage a lot of common infrastructure.
Okay, another question from the audience?
So as we move more open and modular, it puts pressure on the integrators, the big integrators, and eats into their profit margins in some ways. Where do you see, or from your perspective, do you see a sweet spot of how much of the architecture and technical baseline maybe the government owns versus how much, where the breakover is for not just innovation, but the ability to own intellectual property and still maintain profitability for some of the big integrators, or even the small innovative guys? Is there a sweet spot there? How much of that baseline do we own versus industry?
So I think that's a great question. So we've been trying to come to that answer experimentally. So, and I guess my first feeling and my first thought about this from the start has been that we should define only interfaces that we are certain we want to use. Right. So we've gone through and we've looked at interfaces that we knew that over and over again we needed, and that they're worth controlling. So we want to be minimally invasive, and we want to control as little of it as possible, because it's expensive and it's difficult, and it ties up a lot of engineering resources for that matter on the government side. When you look at, for instance, modular OpenRF, what we've done we've taken an experimental approach to try to find the sweet spot, where we took the lowest hanging fruit, defined first the simplest possible useful interfaces that get us a whole bunch of goodness, and then we've been incrementally going deeper and deeper in to see how complex the interfaces become and how much benefit we get from them. So I don't know, I think a priori where the sweet spot is, but we are trying to find that experimentally. The standards are being, as we develop them, are incorporating only elements that we're very confident that we want to use. Interfaces we know that we need to have access to meet our goals. And we want to leave industry's black boxes with IP alone, and we want to, we just want well-defined interfaces to those black boxes, and we don't want to go any further into those black boxes than we have a clear use case for.
Yeah, I think it's really going to be up to vendors to deliver a better SDR or a better radio head. The only thing that we're specifying is the interfaces, the communication between components and how that occurs. But what occurs inside the module, on the module, if you can build a better SDR, a better radio head, a better single board computer, then that's where we see industry providing us the most capability that we can get into the form factor that we're requiring.
Or even a better application. I mean, you could write a purely, completely black box of software that's completely your own intellectual property, that runs on a processor and accesses these interfaces, consumes information, makes decisions, and causes actions. This doesn't stop you from doing that. In fact, it really opens up opportunities for folks to come in and do that. So if you don't have to be an expert at building an amplifier and at integrating a system on a platform to play in this now, because the interfaces are published and understood, so folks can focus on what they're good at and bring that piece to bear.
Thank you. Look one more time to the audience for any questions. And not seeing any, I'm going to turn back to the panel here for any final comments they might have. So we'll start, or just open up to anyone.
Nope.
You, Mark?
No, I just wanted to say thank you very much for having me. I appreciate it. And if you have any questions, I'll stay afterwards. Thanks.
Yeah, thank you very much for coming out. If you do have questions, I believe there was, in the package, there is an email box that you can drop questions to, and they'll be routed to the appropriate people to. We got one more question coming up.
Oh, sorry, I didn't mean to interrupt.
That's fine.
But, do you guys have a wish list of capabilities or modules or whatever that you'd like to have in the future that you don't have, that aren't in the program or whatever? And if so, what's the URL?
So, as part of the industry day that I spoke of, that we're trying to kick off here in the next couple of months with C3T. So it's not. So what's going to come out is an announcement for the industry day and an RFI. And that RFI is about 20 questions. Those 20 questions are sort of where we see we may need a little bit of help. And so what we're going to ask industry is to respond to those questions with a short white paper. We would like that white paper to be non-proprietary so that not only the government but then our CETA contractors can easily look at it. We can share it with them, evaluate them, and get feedback to you. So.
We've got a pretty nice video kind of describing the work we're doing and a little display next door. So I'll be standing by that for a while after the briefing. I appreciate everybody's time.
All right. Thank you, everyone.